All right, today we're digging into a really fascinating challenge at the heart of AI. We're not just talking about teaching a machine to read, we're talking about teaching it to reason like a scientist. So let's jump right in.
It really all boils down to this one critical question. We've all seen AI that can write poems, make incredible art, but can it do one of the most essential things in all of science? Can it actually read a super dense, complex research paper and just tell you, in simple terms, what it all means?
And the answer, as you probably guessed, is, well, it's complicated. It's not a simple yes or no. And to really get why, we've got to first understand the big problem that AI is up against right now.
Okay, so this brings us right to the heart of the matter, what we're calling AI's scientific reasoning problem. We're talking about a leap, a huge leap, from just finding facts to truly understanding science.
Think of it this way. A lot of the old AI tests, they're basically trivia night. You ask it, who is the first person on the moon? And boom, it finds Neil Armstrong in some text. Easy. But scientific questions, that's a whole different ballgame. You have to understand the context, weigh the evidence, make sense of statistics, and then come to a conclusion that might just be maybe. It's the difference between just finding a name and actually interpreting a result.
And this quote right here, it really gets to the heart of how researchers even test for this stuff. They use what's called a question-answering task. It's like their yardstick for AI intelligence. Why? Because if an AI can answer a really complex question, it proves it can reason and infer, not just search for keywords. So to really put this kind of scientific reasoning to the test, researchers realized they needed a totally new kind of exam, a much harder one. So they built it from the ground up. It's a dataset called PubMedQA, and you can basically think of it as the final exam for any medical AI. Okay, and the way they put this thing together is actually brilliant. So first, they found thousands of real medical research papers that literally have a question as their title. Then they took the summary of the paper, the abstract, but, and this is the really clever part, they chopped off the conclusion. That becomes the context the AI has to read. The real conclusion, that's the secret answer key. And on top of that, they had a human expert read the context and just give a simple yes, no, or maybe answer.
And believe me, this was a massive effort. The whole dataset is broken into 3 parts. You've got over 200,000 artificially generated questions just to kind of warm the AI up. Then there are more than 60,000 real questions for it to practice on. And finally, the real test, a core set of 1,000 questions, each one carefully labeled by a human expert. That's the final exam.
And this diagram here, wow, it really shows you just how complex this test is. We're not talking about one simple type of problem. The AI has to be able to handle everything, from figuring out if a therapy works, to understanding cause and effect, and even interpreting tricky statistics between different groups of patients. It is a truly comprehensive exam of scientific thinking.
All right, now for the fun part. Let's actually break down one of these questions. I want to see if you can reason through the evidence. You think you can beat the AI? Let's find out. Okay, so here's a real question pulled straight from the dataset. It's asking, do preoperative statins, that's a common cholesterol drug, do they reduce atrial fibrillation after coronary artery bypass grafting? In other words, does this drug, given before heart surgery, prevent a specific common complication?
All right, now you're the AI. This is the key piece of evidence you get from the paper's abstract. It says, postoperative AF was significantly lower in the statin group compared with the non-statin group. What does that mean? It means the complication happened in only 16% of the people who got the drug, but in 33% of the people who didn't. And that little p equals 0.005? That's just science speak for, hey, this result is legit, it's statistically significant. So, here's the big question for you. Based only on what you just read, what's the conclusion? Does the drug work? Is the answer yes, no, or maybe? Go ahead, take a second, and lock in your answer. Did you get it? The correct answer is yes. If you said yes, you got it right. The data clearly shows a significant drop in that complication, so all the evidence we have points to yes. And that right there? That's the exact kind of logical leap the AI has to make.
Okay, so we've seen what the test looks like. You've even tried a question yourself. So, how did the AI actually do on the real final exam? It's time to check out the final scorecard.
All right, let's introduce the competitors. In one corner, we have the majority baseline. This is just a simple program that always guesses yes, since that's the most common answer. Pretty basic. In the next corner, we've got BioBERT, a real heavyweight. This is a state-of-the-art AI model that's been trained on millions of biomedical texts.
And finally, our human champion, a qualified MD candidate, man versus machine. And here are the results. The simple baseline guess, it gets it right about 55% of the time, so a little better than a coin flip. The super smart BioBERT AI, it does way better, hitting 68% accuracy. That's pretty good. But the single human expert still comes out on top, with 78%. The takeaway? The machine is definitely learning, but it's not ready for its MD just yet.
And that 10% gap, that's the real story here. That gap is the current frontier. It's how far AI still has to go in this specific kind of reasoning. I mean, the AI is impressive, for sure, but that last 10%, that's the huge difference between being a helpful tool and being a true scientific partner.
So what does all this mean for the future? Where does AI go from here?
And this really matters, because it's not just some academic exercise. Building an AI that can actually understand scientific research, that's a huge foundational step. It's how we get to tools that can help doctors make better, faster decisions based on the latest evidence, and help scientists sift through absolute mountains of data.
So the next big hurdles are pretty clear. The AI has to get way better at understanding raw numbers without any text to hold its hand and explain them. And maybe it could learn to do more complex stuff, like trying to write the full, long conclusion all by itself. I mean, the ultimate goal here is to create an AI assistant that can literally accelerate the pace of scientific discovery.
And that really leaves us with a final big picture thought. Look, we're not there yet, but projects like this, datasets like PubMedQA, they are absolutely paving the way. Just try to imagine a future where an AI can read every single new medical paper the moment it's published, connecting dots that humans might miss, and helping us find the next life-saving breakthrough faster than we ever could on our own. What would that world look like?